Yeah, sadly, I think a lot of people left the industry that probably would still be here, that are my vintage, that carries. No, I mean not maybe a little young, that and that carried a lot of knowledge about petroleum engineering and whatever engineering or geology that we had. And I'm not saying that it's lost, but as we turned around and suddenly everybody expected us to ramp back up to full capacity, and you know all the rig hands are gone and the frac hands are, it was just horribly managed from a national security standpoint.
Yep.
And from a world security standpoint, as we're seeing right now, that we play a very important role in world stability and world peace in terms of providing energy to the cheapest form of energy, not the cheapest, but a very relevant form of energy to the Western world. And so, I mean, as far as data goes, it almost seems like, okay, you look at the unconventional space, all the land is most of the land is claimed. There's not a whole lot of secrets left around. Oh, if I know this, I can go capitalize and get this, lease this acreage, or blah blah blah. It seems like as an industry, we probably should be more open with each other in terms of the cross, trading data, cluster spacing, for example, or frac designs and things like that, so that we can all benefit from it. It's like, and I know that's something that ain't going to happen just because of the politics of companies, but it's like, we may be forced to make it happen, because as someone who's worked in companies that are very secret, working companies that are open, working companies that want tit for tat, and now we're fortunately in a situation at Ranger where we have continuous acreage position of 100 and something thousand acres across all the fluid windows in the Eagle Ford. So we're somewhat kind of our own little learning center for the Eagle Ford, and our challenges are spacing and cluster spacing and well spacing, frac design as we go across these different fluid windows, and normalizing it with pressure and petrophysics and GOR, and so anyway, a long-winded answer.
No, it was great. And I'm going back to Claudia because you guys worked together at Chesapeake, which I think, at least for in the beginning of that time, I don't know if you guys know it, but Claudia was like one of the absolute first engineers hired out of, I guess, college for Chesapeake. And at the time, Claudia. Yeah. So Claudia can give like the story of how small Chesapeake was at the time, to how large they became, and then go back to the data, like when it comes to secrecy of sharing data versus now. Like I even think in my own career, in a sense, like having meetings like this open with a group of people, we much harder to pull off like 5 years ago, 7 years ago, whatever. So can you comment on those two things? How your way into becoming kind of Bruce became actually your coworker later, but that's another story. And then touch upon that last item.
So the question was how to touch on the data trade.
I'll get back to the question later.
No, 20 years ago, I was very fortunate to start. If you were to start in that unconventional world, in my opinion, right, Chesapeake at the time was one of the very few companies across that was chasing that concept. And as a, inexperienced engineer, it was a very, very valuable experience for me. Now, I wasn't really involved in the data trade and data analysis at the time because I started my career at the field. What I can tell you is that was an invaluable experience for me. But I do remember going to the file room, which literally was a room full of files, where you had to go in there and check out your file for your well, and sign a piece of paper to the lady that was at the front to go take your file and promise to get it back and sign it off again. So we have come a long ways from there in just the past 20 years, right? We have, as a talked about as an industry in many ways, we have ramped up consortium initiatives like this one. There was a recent initiative to try to do a bit more democratization of data through some type of data consortium alone. But we still have a bit of a reluctancy for many reasons, right? Legal and our industries have, it's more challenging when it comes to many other ways, right? We have to deal with mineral right owners, we have to deal with many legal angles that perhaps other industries are not as, it doesn't involve them as much or doesn't influence them as much. But it just, the evolution of it that I have seen, it's very exciting to me because we gives us an ability. I have seen the democratization of data just from the silos that we used to have. And this is not just pertaining to my particular employers. I saw this across the industries that you are the production engineer, you're the reservoir engineer, you're the geologist, and by God, you're gonna live in a different world, right? And that, I've seen it change, and that gives us a tremendous opportunity to see everything through the multidisciplinary lens. And I think that's an invitation, right, for everybody here to actually think about it from different angles. When you are doing an analysis, what does that mean in the context of production? What does that mean in the context of geology, and so on and so forth? Because at the end, in my opinion, production improvement is it's got to be a multidisciplinary definition. Yeah. To me, it might mean something. To the facilities engineer, might mean something else. And we probably have are in the best position space that I know of right now, after 20 plus years, to actually look at it from that lens. And it's exciting.
Devon, with you guys are pretty open at Devon, sharing, like, very active in the technical scene, a lot of papers. But from when you started to now, in terms of like how secretive it is in terms of sharing data and stuff, have you seen any improvements there?
Yeah, no, we definitely do a lot more knowledge sharing sessions, whether it's larger consortiums like this or just one-on-one with our nearby OVO partners. Definitely ramping that up more and more. We now have people whose large majorities of their jobs are talking with other companies. I don't say it often, but need to also give the government a little bit of credit, which is a weird thing to say. Start thinking about like the HFTS, 1, 2, 3, phase
Right.
1, 2, 3s that are coming out, that whether the DOE started funding those initially, and that's done a good job of getting multiple parties in the same room, talking about similar data sets, looking at things differently. I think you're starting to even now see that funnel down even more to going to the state level, and then even private companies saying, hey, let's go do similar projects and join up and share the costs. So you're now seeing states that are approaching private companies saying, hey, we want to do a HFTS-like project because we're interested in things like EOR. And they obviously know they're going to get more tax revenue if we can get more barrels out of the ground. And so they're willing to front money for us to go do these science projects and bring everybody along. So it's been really exciting seeing a lot more of that cross-company collaboration and even going into the public sector.
And Gustavo, since you're not only the only one that worked for an NOC, but you're all, I think, also the only one that worked for a service company, unless Bruce have some jacks up his sleeve here. But working, like, you've been on both sides of this game, trying to get access to data. What's your take on this in terms of whether it's you feel it's easier to share data internally, externally with other operators?
Well, look, right now, when I was working in Halliburton, we never was the owner of the data, right? Never. We, as a service company, we perform the frac or perform the different kind of treatment or doing characterization or study evaluation, but we never was the owner of the data. So access to the data is part of the whole, project. So that's consuming more than 60-70% of the total study to complete collecting the data, analyze the data, using all the information, right? Right now, after 8 years in BP, I see, some kind of progress. So we have a better, I would say, accessibility to the data. Everybody have access to the data inside our organization. And the data is already, analyzed, cleaned up, and et cetera, et cetera. However, something I can see very difficult to join is to, for example, in Permian, we have 1 acre here, and then Coterra is in the north, and then, ConocoPhillips in the other area. So it's so difficult to sharing information between one and the other. So that is something that someday, as Bruce mentioned before, so someday I want to see that, so that we can, exchange the data, trade in the data, see, what happened in your border. So, understanding what's happening in the other border. And exactly what we need to do is, improving our process. This is something that, we still don't.
Can I tell a story?
It was like reading my mind. Bruce, go for
It
it.
involves data, it involves the DOE.
Go for it.
So, as I mentioned, I started out in California, and because you guys are familiar with California, the Coalinga field kind of sits in the middle of the valley. Fascinating, huge reservoir, multi-layered, conventional field. It's been around since the turn of the 1905, I think, was the discovery well in Coalinga. And in the early 80s, after the first major oil shock, the DOE funded this polymer project with Shell Research. And when they found the perfect reservoir that had perfect mobility ratio for polymer, and they were going to do a polymer test in Coalinga on this section of land. Well, Shell's acreage position kind of set in the middle of this huge, probably, 20-mile long reservoir that actually outcropped somewhere in the coastal range, and it went off into the valley. But so I took over the field as a reservoir engineer after this polymer project had failed miserably, and I started looking into it. And first of all, I looked at the volumetrics and all of the, I think we called them view graphs, which were the old PowerPoints that you had to put over those projectors. The recovery factors were 20% or so on primary before they started injecting polymer. So it's like, okay, well, that kind of makes sense, primary recovery factors in those ranges. And so I started digging into it a little more, and then I found out that was they were counting the cumulatives just based on what was electronically stored in the Shell computer system, which started in 1935 to 1980. So it only had 50 years of cumulative production in there for this oil in place, right? So like, where's this thing was discovered in 1905? Where's the first 30 years of production there? Oh, you've got to go to the DOG, the Department of Oil and Gas, and it's on microfilm, and you have to dig into the microfilm and make hard copies of all your. And I go, okay, we'll do that, and then also make hard copies of all the property owners, Chevron mainly, up dip of us and down dip of us, and we're going to do a material balance over this strip of land, right? Because what had happened was when they started injecting polymer, guess what? It went on a vacuum, and there was absolutely no response. And all the lab guys at Bel Air said, "Oh, freaking operations people, they mixed it wrong. They had the wrong viscosity." And the operations people go, "No, we didn't mix it wrong. It just went into air." Right. So we spent, the tech spent a good 6 months figuring out all these cumulatives, and we did a mass balance along that. And lo and behold, you guys are familiar with California reservoirs. Gravity drainage is a very dominant mechanism there. And what happens in gravity drainage is your residual up dip to air is essentially nothing, right? It's less than 5% oil, because what happens, these things are so porous and permeable over time, the down dip guy, he's a happy camper. And lo and behold, Chevron had made, when we did this, Chevron had made 300% of their oil in place by sitting down there draining. And that air oil level had long passed where we started injecting polymer. So we were basically injecting it into an air sand. But anyway, make sure your data is complete.
I love it. It was actually funny because I was going to ask Bruce to take a war story to end this, but this is a perfect end. So just to wrap this up, probably what we need more of is to just use our brains as engineers, not just click buttons and get colors for dollars, but we need to be a little bit more analytical. More data is great, but be thoughtful of what data we can get, and the good quality data, let's analyze more of it. And that's a constraint from also resources sometimes. When it comes to data liberation, let's make sure to move in the direction that we are moving, where data inside of a company is easier to access, so it is more accessible to also a multidisciplinary team. It's not only a responsibility, I think, on the oil companies, but also on the service providers. License limitations, it's like a barrier for that stuff. So make sure that you have unlimited number of seats. Anyways, and the last thing is definitely make sure that you don't do polymer floods is not a good thing. That's my takeaway.
Polymer floods and gravity drainage reservoirs up, not good.
Exactly. Thanks to the panelists. There's still food, there's still drinks there. We'll just keep it going here for another hour, and then we'll go over to Flight Club after that.
Question real quick.
Yeah.
So data analytics during that weird time in the industry was such a huge thing. I mean, we can all sit here and say, AI, there's a button, hit it, it'll solve it, right? And to your point, Mateus, of using the thing between our ears, because what's ended up happening, in my opinion, is it's migrated up to all those people that are investing in us. So they're using those tools instead of using the thing between their ears to make those business decisions. Because like it or not, we can collect all the data that we want to and come up with all this technical analysis. They just want to know if they're going to make money. So what my question is how do you, there's a balance there. So where do you find that point of weaning them off of that data analytics AI to bring that technical piece back up? How do you convince that? How do you convince management in those instances, but then go up to a financial model that then they plug in? Does that make sense?
That's a super relevant question for the panel, actually, because we have maybe all of you guys are managers. Claudia, at least Stephen, you just became a manager. So I'll pass that question over to you. How do you convince you? It definitely involves whatever beer that is, Carback.
2 weeks into this, I'm sure I got the answer. No, the biggest thing we've seen in Devon, we've all been there where you go to give a bunch of data to the data science team, and they come back, and I got this really great correlation that the higher the API number, the better the well.
Those kind of correlation. We'll have to use that one.
That it happens far too often, and
They still do that?
it still happens. Yeah. You started it, Bruce.
No, I tried to end it.
But what we've seen lately, though, is we're really starting to empower more of the technical reservoir engineers and geologists to start. We have what we call citizen data science programs, where we're trying to bring that data skills much more to the people that have the brain between their ears for knowing what's going on and what makes sense. And so they by no means are the smartest people in the room when trying to work through these big data programs, but we've got people supporting them, and they're the ones doing the actual crunching of the data now. They're the ones putting the logic behind it to make sure they don't end up with, hey, API makes the best correlation of performance. And so I think a lot of it is making sure you have the right people doing the right jobs. And it may not be the best person at that specific task, but given enough mentorship, they'll end up with a better result than the best data science person.
Claudia?
So, having worked as manager before and having worked private equity and dealt with investors and, VC firms and before, and now currently in a very technical role as well, I think, we have to think back. This AI, ML world, it's not new. It started many, many years ago. What's new are probably the versatility of the algorithms. Computational power was a game changer. If you think back of the first AI algorithms that beat the famous world-renowned champion in chess, that was what, 1950s? So now what we have, though, is computational power and more versatile ways of doing the work that actually enhance what we can do. And we're going towards something bigger, right? That needs to continue to build. It's not stagnant. But in our context, in the different layers of the organization, we cannot all we don't all have that knowledge. Here it's about harvesting the talent for what they're good at and putting them together as a team, in my opinion. Keeping the human in the loop again. So what we have seen that works is, you're going to have your data scientists, and if you let them loose, they might come back and tell you that the best correlation is tied to cows at the surface, right? So it's probably not the best thing. But if you actually put them together with the technical expertise and just use that to challenge the knowledge. So listen, statistics are statistics, right? Math is math. Computer science is computer science. It's based on math. We can leverage that. And if you think about what data science is, it's just the intersection of computer science, statistics, and applied math. So we can leverage that. It's just the context in which we leverage. And that's where the human in the loop comes into place. The experts, right? The ones that have been through war and have, made the down dip guys really, really happy. So those are the things that we have to get them together in a room and challenge each other. And that value gets elevated at the chain. When you get in front of investors in the finance world, all they want to know is, am I making money and can you prove the repeatability of this? And, likely if you have the underlying basis, technically speaking, you might be able to do it.
Is that a good answer, Brian?
Oh, yeah. I mean, it's a challenge, I think, in our industry as a whole.
Yeah.
Brian's point, it's finding it harder and harder to buy an asset because in a lot of instances, he might be overmapping it, for lack of a better term. When it's keep it simple, stupid, just tell me what a multiple is, and then we'll go into it. And Bruce's point of, we wish we could all live in harmony, do a big group hug and sing Kumbaya and share data. Well, no, that's not going to happen. Being at Chesapeake at the same time these guys were, holy crap, we all know our data. It was don't tell anybody, don't tell applications. It was even within our own company.
So to Brian's point, Aubrey would walk around outside. If you guys have been to the Chesapeake offices, it's like a campus, so you can see through all the windows. He'd walk around, and if anybody had a map on their office wall, he'd look and check the walls to make sure that. And he'd call them, and he'd call their boss the next day and say, "Get that blah 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 map off that freaking wall right now, because somebody might be stealing information from us."
It's crazy.
Yeah.
But no, I really appreciate you guys and the open discussion. It's great. Fantastic.
Perfect.
Back in the old days, we had data analytics guys, and we called them. They were junior reservoir engineers.
A bunch of bad guys at Chesapeake to do all that stuff. It was like, this is one of the best
Because they
investments out
had
there.
physics background. They knew why these things were working.
Yep.
They weren't trying to find, because a good well had 2 trees on it, they're not going to try to find another location with 2 trees,
But I go back to it. There are tools. It's about what's in the engine, right?
Absolutely.
We can tell horror stories about numerical models. We can tell horror stories about how bad, RTA has led us astray. There are tools in the toolbox, and it's again to go back to the human in the loop. How are you going to use the tool? In which context? And I think that's the important thing to remember.
Yep.
And what platform? Okay.
All I want is a recovery factor visualization.
You get it, Bruce. Stiana's promised you to.
I'll make it work.
That's good. At least you know who to call. Don't call me, call him. Anyways, we'll jump off the team calls here for those that are still there. And thanks to its panel once again, really good. I know we haven't done the applaud thing today, but let's do a little one for them. Appreciate it. And then there's